Hey guys, this is Carl, and this is week 6, number 3 for Management Research Methods, 650. And kind of following with the current events, what we have here in terms of probability and normal distribution. Normal distribution is what you would think is a normal bell curve, just as discussed in your text. But for this example, Olympic downhill skiers train to master steep slopes in under a minute. Skiers are modeled to have a mean, or average, as they say in statistics, of 56 seconds with a standard deviation of 5 seconds. If the skiers are well modeled, what does that mean? That is just a traditional normal distribution. No skews, nothing to the left or the right, as your text describes. What is the probability that a randomly selected skier from any country would finish within the following ranges? So what we're going to do, a key equation throughout all of this is right over here, our z-score, which equals y minus our u, or what you would call our mean, divided by our omega, or standard deviation. And our y in this case, in all of our examples, the way this is phrased, the y are these values right here, what we're looking at, the ranges or values that we're trying to figure out if a randomly selected skier would have a time above or below or within a certain range. Standard deviation, 5 seconds. That value, that u, is our mean, and we already know that it's 56 seconds. So what we're going to do now is just going to head off the bat. So part A, what is the probability 77 seconds or below? So to get this, we're going to use our equation. We'll input it into Excel for our z-score right here. This equation is key throughout this whole exercise. And so we're going to start out with our y value, which in this case is 77, minus our mean, which we know is 56. And then we're going to divide by our standard deviation, which in this case is 5. That gets a value of 4.2. Now, what do we do with that? That's our z-score. Now, our z-score, we're going to use technology. In this case, when the textbook says use technology, or MathStatLab use technology, it's in Excel. For this value, you want to find the probability. And so what this would be for a lot of everyone is these norm S distribution. Just a key factor, norm S distribution function. The function is available in Excel earlier, and it returns the standard normal cumulative distribution. This is what we're looking for. And so with our z-score of 4.2, we know that for a fact, we get a 99,998. What does that mean? That 77 seconds or below, that 99%, that the probability is 99% that skiers will fall at 77 seconds or below. Now you think, wow, that's really high. Well, of course, it is possible, because of look how tight knit. The average is 56, a standard deviation of 5, so at the very least it's 61 seconds, or 56 plus 5. So it's reasonable to think that almost all of the Olympic skiers would have 77 seconds or below. Now above 80 seconds, ooh, that could be pretty tricky. But the same instance, what we're going to do, we're going to do 80 minus our mean, 56, divided by our standard deviation, which is 5 seconds, 4.8. Pretty close. We're going to use our norm S distribution function again. This is our... Now, a key point is above 80. Now, this value gets us below. Notice below is just what it is. Now, to get above, remember, this is the bell curve. We want to go 1 minus the value, because this gives us everything be at the value or below. We want to get above. We want to get above 80, so we need this, and this will give us our probability on this side. So 7.988. So what does that mean? That is a 0.000001% chance that somebody is going to get higher than 80 seconds on their run. So very low probability, very, very low actually, which is understandable given the context and our variables right here. Now between, this is a very good point to make, and very good evaluation. When we have something between, what it is in this case is what we want to find is the value, the probability rather, of 40 or below and 50 are below, and then we subtract the two, and it gives us the difference, or between. So we're going to do this separately. So we're going to do our z-score calculation for 40, which is 40 minus our mean, which is 56, divided by 5. Okay, that's 3.2. And then over here, we're going to do another one. It's going to be 50 minus 56 divided by 5 gives us that value. Okay, you can kind of see where we're going with this. So we're going to do our norm S distribution function. Our z-score is the probability. It's pretty low. And in this case, the same thing, 1.2, pretty low. All right, so now we got two probabilities, one for 50 and one for 40. So now what we're going to do is we're going to subtract the two probabilities, and this will give us the difference. So there you go, at 0.114. Now allow me to just so far, let me give you a context of what we're doing right here. Is point that times 100, give you a good sense of it, the 99.9%. So it's kind of a quick way. This number is going to be a little funny because it's so small. So yeah, so it doesn't help us much. But in this context, in terms of probability, just to help you out and visualize and kind of understand what we're talking about, 11.4%. So when you're in your text and your answers, these are the actual answers right here. But I just want to provide you in terms of percentages. What would that look like? 0.998, 0.793%, actually 0.0000793%, and then 11%. And another way to do it visually, if you're curious about it, is to actually just put this value in percentage in the formatting function. As you can tell, it would be like here, it would be right here, and you could format the cell and you could add percentages to it. Either way is fine, but in my stat lab, key point is to make sure that these are your values. So it was just FYI, but when you answer your questions, make sure you put them in this case like this. So 0.11%. So 0.11, 11% chance that one of the skiers is going to have a time of between 40 and 50. And that's your gold medalist more than likely. That's pretty fast. And so above 100 seconds, you can consider it the worst of the worst. You know, who is going to have above 100 seconds? So we already know above 80. So you can imagine above 100 is pretty much going to be next to none. But for the sake of exercise, we're going to try this again. So 100 minus 56, our mean, divided by our standard deviation, which is 5, gets us 8.8. Now this is going to return a very, very small number. And this is pretty much, yeah, it can't even, it's 1. So, and what does that mean? That means that there is, and so that's 1. That's essentially 1, rounded off. So what does that mean? But remember, this is above. See how we did above here is we subtracted by 1 to get us our value. So you can imagine here, what's it going to be? 1 minus 1, that there is virtually no chance that a Olympic downhill skier is going to have a higher run above 100 seconds, given the context of the mean of 56 seconds for all skiers and then to standard deviation of 5. So there is virtually no Olympic skier that will have this if they're randomly selected. So I hope this helps everyone. Just feel free to let us know if you have any questions. All right, thanks so much. Bye-bye.